Hello everyone, and welcome to the MT Half Marathon MT Evaluation tutorial. I'm very happy to present Catarina Farinha and Ricardo Rey today. If you've attended the previous session, you've met Ricardo already, and you already have some context on what the topics are going to be about. Ricardo and Catarina are co-authors of COMET, the state-of-the-art MT evaluation metric that you all know about already, and of the MT telescope tool, which will be the focus of their tutorial today. So I'm just going to give first some background on them. Catarina has a background in biomedical engineering and a PhD in computational chemistry, and she's been an AI researcher at Unbubble for over 2 years and has dedicated most of her time here to work on MT evaluation. As for Ricardo Rey, he works at Unbubble as an AI research engineer, and he has a background on intelligent systems and software engineering. He's currently doing a PhD on MT evaluation at the IST, the University of Lisbon, under a collaborative program between Unbubble and the UNESCO ID R&D Institute. So without further ado, I'll pass the mic to them so they can tell you all about MT evaluation and MT telescope.
Thanks, Marina. So I guess Ricardo will share on the chat our tutorial, and I will sharing here. So basically the tutorial is self-contained. Everything that you need to install and the data that should be downloaded, it's here. The first part is about just how to evaluate several metrics. We'll start by Sacred Law, Comet, and CHRF, and then we'll move to a more interactive part with the MT telescope. So I guess everyone can start just by clicking on the link and setting up the environment and downloading the data. Everything should be pretty fast. And if you have some doubts, we are here.
Yeah, just the tutorial was done for anyone to be able to do it on your computer. If you have Ubuntu or Mac, it doesn't work for Windows. But you don't need a GPU to run the tutorial. Some things will be slightly slower, but you still can do everything before the end of the hour.
I think the best option is just we also do it, and
yeah. So just a little bit about installation. Here where I say the path to the env, it's just a name that you can give to the env. I'm going to put it env 3.8. Okay. In my case, it's this command. Maybe not. This is Murphy's Law. It should be right.
So we are having some
I can't
demo tutorial problems, but the idea is just to create a virtual environment so that then we can install everything that is needed. And this should also be interactive. So if you are following, or if you're also having problems, let us know.
Okay, I had a VM here, but the first part is just to create the virtual environment.
And then you just need to active, and then we need to get data for the tutorial. So this data is part of also from the shared task. We have chosen some that is from Russian to English, And we specifically choose some that will be helpful for our tutorial, but still quite small, so that we can iterate several times with several metrics. And in the telescope, it doesn't take too long to do it.
Yeah, and you should be able to run the wget command to just get the data, and then the tar_xf command just extracts the data.
Just unzip it.
Yeah, so if you then do head tutorial, for instance, source, you can see that the first segments are in Russian. Then you also have the references.
And the online A, and then we have two systems, online A and online B. And those are the systems that throughout the tutorial we are going to be compared. Is everyone following? So does anyone have the data, or are you having problems with the wget and downloading the data? If not, we'll just assume that.
Yeah, let's just give a little bit more time for everyone to create the env. But yeah, if just online A and online B systems on the shared tasks usually are anonymized systems that are either Microsoft, Google, DeepL, so they are basically empty providers. And we want to know, for instance, which empty provider is better. If it's okay, so B is Google, A is Microsoft. So we are comparing Microsoft against Google.
That will be interesting.
Yeah.
Okay, maybe we can.
Okay, so after you get the data,
we move to part one.
We move to part one, yeah.
Install first Sacre Bleu and also other metrics. So we'll focus first on Sacre Bleu and Bleu, like Ricardo said in the previous presentation, they're lexical metrics. Yeah. So you have the command there, just need to do pip install upgrade pip and then pip install Sacre Bleu. And just to confirm if everything is ready, you can do Sacre Bleu help to make sure.
Yeah, and don't forget the pip install upgrade pip, because sometimes you get an error if you don't upgrade your pip command. Okay, in my case, I'm using
the
a VM that was I already tested the tutorial on, so I have everything installed. But if now I do Sacre Bleu help, it basically prints all the options command line interface of Sacre Bleu. And Sacre Bleu is called Sacre Bleu, but it implements other metrics than just Bleu. And it implements CHRF. It's basically based on lexical metrics, but it has some interesting things that we are going to explore, namely the statistical testing with pairwise bootstrapping. And yeah, it's still like, we advise you always, if you are doing your development or if you are testing your systems, we advise you to do more than just one metric. So we advise you to run, for instance, CHRF, Comet, and Bleu, and also to try to report statistical testing over those segments or those systems.
Okay, so if you reach that part, you can continue with the tutorial, and the next part will be just to see how we can run Sacre Bleu for one system. And we have there just to code the command that you need to run for running, for example, online A, and obviously for online B it should be the same, except changing the name of the system. So Ricardo is also going to do it.
So here is where you specify the metric. You could do CHRF if you want to do another metric, but let's just get
For now, yeah.
bus scores. Oh yeah, I should be on the tutorial data.
Okay.
So
Very fast.
it's very fast. This is just a few segments. By the way, don't conclude after this tutorial that Microsoft is better than Google or Google is better than Microsoft.
We don't want to make any claims.
Especially because it's just 400 segments. It's not a lot of data.
Actually, it's just 100.
100, okay. So this is the score for online A and the score for online B. And as you can see, there is a small difference between those two. Now, the question is, this is one of the intuitions about the MT telescope. We could just jump into conclusions and say that online A is better than online B. Yet that's very unfair because it's just a sample of data, and also the score difference is not that high. So we need more information about these two systems. And if you go to Sacre Bleu help again, you have here paired significant testing for multiple system evaluation. And this is what we want to use. So we want to pair these two systems and see if there is some statistical difference between one system or the other. The command that you need to run is this one.
Is also in the tutorial.
So here is where you put in this dash I is the input for your systems. And you want to input system A and system B. And you want to select a metric, and you want the PBS, it's the PBS, it's this one. Yeah.
It's perform a paired test using Bootstrap to replace.
Yeah, it's just a flag that activates this statistical testing. And where is the other flag? The PBSSB, it's somewhere over here. It's this one. It's the number of times you want to do the testing. In Bootstrap resampling, what you're going to do is you are going to split your test data into several chunks, and you are going to reevaluate each metric for each one of those chunks. So let's imagine we have 100 segments. You are going to split those 100 segments in 1,000 different ways. And basically for those 1,000 different ways, you are going to run BLE. And why we need it? We need it because BLE is a corpus level metric. So we cannot just compute the segment level scores for BLE and then try to use, for instance, t-test. We need to actually recompute the metric for each partition of the data that we have. So what we are going to do is to create several partitions and measure how many times one system is better than the other according to a certain partition. And this is going to kind of simulate having multiple test sets within just one test set. So we are going to set PBS to 25 because we don't have a lot of data. And since we don't have a lot of data, like it doesn't make sense to use 1,000.
Yeah, to make so many different test sets because actually you don't have a lot of data. But the idea is basically that like trying to replicate multiple test sets and to see if in all of them, with 100% of them, the BLE is still giving, for example, online A the better system, so we can be more confident that online A is better than online B.
Yeah.
So we have the results there.
If you look at the results, you can see that the p-value it's 0.38. So it's very you cannot say that the first system is better than the second system with statistical significance. So you don't have a way to reject your null hypothesis, and your null hypothesis it's always that they are equal. And since you cannot reject that, according to BLE, you cannot say that this system is better than the other system. And this is very important to run. Like every time you do MT evaluation, you should look at these statistical testings.
Is there any question about this?
Is everyone able to at least run the Zagreb help so far?
You understand how to change the metric. It's pretty simple, but for people that are not using MD evaluation, it might be the first time that they're doing. So if you have any problem, let us know. Doing the tutorials online is always harder than to be in person, because then we could just go there. But we are here to answer any.
But we have one
problem.
computer with camera and the other with chat.
Yes, so we are we are trying to be the most presential as possible. But again, if there is no question, maybe we can just move. And now we are going to online to install Comet. And
no, wait, just
no. You already
okay. We have some questions. Okay, to run in the exercises, you also have to run CHRF. As I was saying, CHRF, you can just
changing that,
put it here. So if you run CHRF, you get an extra column with CHRF results. And if you notice, the p-value for CHRF, it's smaller. It's still not enough for you to say that one system is better than the other, but it is smaller. And this makes sense because CHRF, it's higher. The performance of CHRF is slightly better. So intuitively, this system should be able, or this metric should be able to differentiate quality a little bit better. And it's giving you a smaller p-value. So
if they're different, right?
Yeah. And here, there is another interesting thing, which is that according to CHRF, the second system is better than the first one. So these systems are very close in terms of quality. Okay, so moving on.
Moving on. So the next part, we are now in part 2. And the next thing that you should do is just pip install Comet Embebble Comet 1.0.1.
Yeah.
So Ricardo already has
everything. For me, it's going to be super fast.
Yeah, the requirements are already in for me as well, if I was going to share. But for you, it should be also fast and quick as well. And again, just to confirm, you can put Comet score help and make sure that it is installed and everything that you need to know about what Comet does. So you have all the flags there and the description.
Yeah.
So we'll just give some time so that everyone is here. But again, if you have any comment or even some questions related to Comet, like in the previous talk, we can try to discuss. Once that is done, I think it should be super quick because it's just pip install.
Torch sometimes takes a little bit longer to install, but not much more.
And the next exercise is just to run Comet again for online A. So it's exactly what we're doing for BLA and CHRF. I mean, Zagreb BLA and CHRF, but now using Comet. So it's Comet score, and then you need to put all the flags that is needed. In our case, we need the source, the target, and the reference, as you saw in the previous talk. And here we also have a flag if you are doing it without GPUs, so that you can set GPUs to 0. And otherwise, it will complain because the default is to use GPU.
Yeah. I'm saying here that I'm not using a GPU, and the machine that I am running this, it's actually very small and slow. So, and still takes like 20 seconds. It's not going to take a long time. If you are running this command for the first time, it's probably going to need to download the models, and that part might take a little bit longer. But you just need to do it once. Then to run inference, it's always just loading the model that you already have in cache, and it returns you a system level score along with segment level scores. And this is something that is slightly different from BLE, because BLE, it's a corpus level metric. So BLE, it's a metric that gathers statistics along the test set of how close or how many n-grams between my hypothesis and my reference I could, like my MT was producing exactly like the reference. So, and it gathers those statistics along the corpus and then summarizes those statistics for you into a final score. For Comet, we don't do that. We estimate the quality for each individual segment, and then we average the quality. The system quality is just the average of the segment level. So when you use the Comet score command, you get not only the scores, you also get not only the score of the system, you also get the scores of the individual segments,
which can be very useful, as we will see next in the following the tutorial.
And also, we have more Comet models available, so you can select with the dash model, you can select other model. And this model, the WMT21 Cometinho DA, it's the model that I presented in the previous talk, where we just replaced XLM Roberto large by a very small encoder. And yeah, the model should be faster. The quality of each prediction should be worse. So yeah, the model is not as reliable as the initial model.
Nevertheless, for the purpose of the tutorial, what we want you to have in your hands is just to see how you can use different metrics, to have this idea of segment level, of confidence intervals, bootstrapping, and then the telescope. So we really advise you to use Cometinho just because of time. It will be way faster, and still results are still useful, not as reliable as Comet, but
yeah,
still worth looking at.
There is a project that is about adding Comet, creating a script to add Comet into validation. Depending on the machine that you are using, you might want to use Cometinho because it's faster during validation, and a good checkpoint according to Cometinho will probably correlate with a good checkpoint for the larger version of Comet. So we just, if you want on that project, you can use Cometinho. It doesn't mean that if you don't have any restriction into your GPU setup, you can just use Comet, normal Comet. Okay, I don't know if you remember, but the online A system had a score of 0.51 more or less, and this online B has a score of 0.56. So according to Comet, online B is better than online A, which it's not what BLE was telling us, but it's the same that CHRF was telling us. So according to, if you compare these metrics, you will see the difference in terms of ranking. Now, we also have, similarly to Sacre Bleu, we also have the Comet compare, which is going to compare two systems. You can pass a system X and a system Y. So you can pass those systems. We are going to perform bootstrap resampling. And here you can also, we have slightly different ways to do this. We asked you for the number of partitions and we asked you for the size of the partitions, but let's just ignore this part for now. We also give you t-test, and the t-test works very well for segment levels metrics, because in paired t-test, it's just a statistical test that you can run to try to
basically compare two
vectors and see if the means are equal, basically.
The main difference is because what Ricardo was saying, if you have a metric like BLE, where you only have a metric, the score for the corpus level, you cannot perform this kind of t-tests. But if you have like Comet, then it's much easier, because then you have the scores for each segment and you just do a t-test to compare it, and then you have the p-value that normally we say that if it is significant is because it's lower than 0.05. And Ricardo now is doing exactly that. So he's comparing Comet compare, online A, online B. So you just need to put X and 9. And maybe we don't need to do the pairwise if you want.
The pairwise?
The t-testing.
The t-test runs automatically.
It runs automatically.
So yeah.
So he's using Comet here, but you can use Comet in to be faster. And then, as you see, you have here the results for the bootstrapping, as in Sacre Bleu. So you can see that, for example, according to the corpus level scores, so the system, the online B, so the 6MY, it was higher. And when we do the bootstrapping, it also shown us that, because in 85% of the times where we did the bootstrapping, it was actually giving the win for the online B. However, when we look to the significance, it was higher than 0.05. But again, we don't have a lot of data. So even actually to do the pairwise t-testing, you should be, I think, more data than what we have now. But at least you know that Comet support is, and you know how to interpret the results.
Yeah. So it always gives you a message over here that will, according to the t-test, will tell you if the systems are equal or if one is better than the other.
But there is much evidence. There is a lot of evidence that actually online B should be a better system than online A, nevertheless. Is everyone following? From time to time, I will just ask so that you are not shy, and you can and should interact with us. Or you think it's too simple and we can move on faster. So that kind of feedback is also appreciated. If not, we will just continue.
There is a message.
Yeah, good.
Okay.
Thanks.
Let's just look here at some things with the scores. If you just scroll up, you will see that we are going to give you, when you run the Comet compare, you are going to give you the score for one system and the score for the other for the same segment. And here we can see that there is a lot of differences. Like if you look at the system on your right, the system always has positive values. The system on your left sometimes has some quality estimates that are below 0. So it looks like that both systems apparently are similar according to BLA, CHRF, and even Comet. There is some, according to statistical significance, you cannot reject the null hypothesis, but you can still look at the scores and see that clearly the system on your left has some outliers in terms of quality. And we can try to isolate those outliers. We can try to go, for instance, to this line over here. And if you check this line, it has minus 25.6 and 0.5 for the other system. So let's try to look at this line.
So for that, we also have the comments there on the tutorial. We just need to copy paste. Yeah. And you are gathering now the segment 7 that Ricardo was pointing at.
Actually, there is an error in one of the commands because I copied pasted this wrong, but okay. So it's online A that we want.
Yeah, of course, we want online A, online B, and
online B, and finally the reference. Right. So let's look at why is one online A and so different from online B. And if we look here, it's the online A is translating this named entity, which I cannot pronounce, into Archangel, while online B keeps that named entity intact. So it really looks like Comet is giving you a good estimate of the quality for online B compared to online A, just because of this change in online into this named entity.
We have a question on, yeah, you were going to unmute yourself, but I just saw that you have a different score. Maybe you are using Cometina, no?
No, it's possible. Wait.
But how different it is?
Yeah, it's a very small, that number is very, let me go up.
I just wanted to say that that entity was Arkhangelsk. It's the name of the city.
Okay. Yeah.
Thanks.
So you got a 0.5204, and here it's 0.5283. So this is a very, very tiny difference. And this
actually, sorry, but that's not about this test. It's about the Comet score command. It's not about the Comet compare.
Oh, not Comet compare. So it was above.
Comet score.
But it's a very small difference, right?
Well, not that big.
You have
0.56.
And you sure it's for the online B? Because the online A has something.
Here, the final one. Yeah, online B score at the end.
Wait. This one, right? I'm gonna just run this on GPU.
Okay. Because that's, I think, for segment 7.
No, it's the system.
The system.
Yeah, the system.
Okay. So let's see.
It shouldn't. So online B, it's 56.
56.
And online I believe it's something similar to that. It's like 51. Yeah, okay.
So that should be online A.
Yeah, you are getting the score for online A.
Okay, yeah, I see.
Yeah.
But by the way, just one thing. If you, that's why I was actually making sure I was running it on the proper way. Sometimes you see a difference in like the third or fourth decimal in Comet scores. They will be completely rejected if you run a statistical significance. And this happens because within the way we train the model, we use in-batch variance to avoid overfitting, and it's something that usually helps generalization. But then it makes small differences in small decimal numbers. So it's not 100% sure that you are going to get the same exact score for same systems. That's why it's very important to run statistical significance when using these new metrics.
But the difference should be very small.
And the difference is very small, and usually you don't notice it at the system level because it averages out.
Okay.
Right.
Should we just move on?
Yeah, we need to move on because of the time.
Yeah. Maybe we can show the MC dropout flag.
Mm-hmm. Okay, so one of the things that I talked in my talk was about uncertainty, and also if you go and you look at the outputs of the segment, if you go and you look for the outputs of the different segments, segment 7 was that one that we just showed, but then you have segment 6 and you also have segment 27. In those and 14, yeah. all of those segments, the predictions of comets for one system and the other system were very off. For segment 7, which was the one that we looked at, they make sense. But for some other segments, I believe it's segment 27, the assigned score for online system B and online system A, it's very unfair because for one system it's very high and for the other it's very low. And if you look at the difference in terms of translation quality, like the difference is not so much. So it's really unfair to just Comet is producing wrong estimates, which are unfair to one of the systems. And as I told you, if you use the
Dropout.
MC dropout or deep ensembles, the study that we did on uncertainty helps you fix some of those scores. And if you look,
I just want to mention as well that the first author of that paper, it's also here, is Taya.
yeah.
So if you want to reach out to her, if you have any questions about these uncertainty techniques such as Monte Carlo dropout and how they were used for Comet, you should definitely talk with her as well. But yeah, the scores of uncertainty could be useful, at least to see in these cases where the scores, if you are comparing two systems, the scores are very different. How Comet was certain about it, if we can trust or not, if there is any problem.
It's D. Sorry.
Okay.
I made a mistake on the fact.
That's okay. If you also want to try, you just need to follow what Ricardo is also doing. So you just need to copy that part regarding the segments and then add the flag MC dropout, and you can put 15. So it is predicting, and we already have the results. And again, we can analyze.
Now the results are very, very, very small.
We cherry pick them. So.
And they are small for one reason, because I did the wrong reference.
Ah, okay. That explains.
So it makes sense because the reference was completely off.
Okay.
Right. So segment 1 is that segment, because the way I did this selection, segment 7 is that segment where the system was actually doing a very nasty translation of a city. But the other segments were also negative scores. And if we activate the MC dropout, they become positive and they actually are much more aligned with what we expect. If you do the same for online B for the same segments, you will also see that the scores drop in most cases, which means that that difference between having two very small, two very similar translations, one was Comet was overestimating and the other one Comet was underestimating. If you just run the MCD dropout, you will get some fixed predictions. And you could also look at the variance to see which ones Comet was more uncertain of. Okay, so we need to move on to
just a matter of time. We will move on. That is with the empty telescope. So it will take a little bit just to install, but it should be 2 minutes. Again, but he's showing how to do it.
No, actually, I didn't have it.
I know. It's installing. So yeah, so we have an idea of how much time it takes. So you just need to do pip install, empty telescope. And one cool thing about empty telescope is that you have 2 ways of using. You could either use the interface that we built using Streamlit, that some of you might know is just a easy way of doing apps and interface really quickly, or you can do everything in the command line. I think that we should try the interface just because it's more interactive, but if you feel more comfortable with the command line, for every exercise, we also have there the commands of how to use it. But Ricardo is showing how to set up the interface. So you just need to write telescope streamlit. And in the next 10 minutes, we will show it through the interface. But again, you have the commands there if you feel.
I have to share this one.
Another, okay. So this is how empty telescope looks like. And what we should first see is that you have there little boxes to put everything that you need. So we are comparing to systems, again, like we were before. So first we need to either click or just drop the source. We are using the same data that we were using before. We also put the reference there, and then is the system online A and online B, again, the ones that we are comparing.
Yeah. The data, it's always these text files, one translation per line.
Yeah, as Ricardo was showing. So basically you have one sentence per line, aligned. And then we need to put the language pair that we are comparing. In our case is Russian to English. And then you just click OK. And the metrics that by default is the one that we are using. You can see in the left bar, it's Comet, CHIF, and BLA. But if you just show how to choose others, we will not use because of a matter just of time, but you have the other ones also implemented there, for example, like blurred score and TER. So here we see how is so now we are analyzing the whole corpus, the 100 sentences that we have been using. And you can see first in that table, the results at the corpus level for one system, for the other, and according to all the other metrics, the metrics that we are using. So the first question that we ask is which system is the best one? And one obvious answer will be just to look at the values in the table and to choose the one according to the metric that you prefer or according to all of them. For example, you see here that actually, like we saw before, Comet and CHRF give a better score to system Y, online B, and BLA says the opposite. But the other thing that you should also take into account is the
bucket spot.
Mm-hmm.
Remember in my talk I said that sometimes you have two systems, they perform very similarly, but you might want to know which one performs more critical errors. And if you look at this plot, it's basically telling you that. And we also saw that from the segments. If we look at the scores, we saw that system X was having a lot of wrong translations in terms of a lot of scores that Comet was assigning a negative result, a negative score, while the other system was not having so many negative scores. And you can clearly see that here. So you have, for system X, you have 12% of the data, it's below the 0.10 Comet score. This is the Comet score that we use for this analysis plot. And you can also move these thresholds. We can try to make it.
One cool thing is that you can put a higher. Imagine that you really don't want any criticals, and for your criticals is everything that is below 0.3. Just put that a little so that okay. A little bit. So now we don't have the yellow, but you can put it like higher. Just put a little bit higher, like 0.2. And then you can see everything increases, but again, system A has more of that critical errors than the other one. And this is super important. Imagine that you are in the industry and you want to put a model into production. This is the kind of things that you want to avoid, because then the clients might complain. Yeah. And so it's better to have a system that might be at the average score a little bit worse, but actually that avoids really bad translations.
Yeah. We can also see at the...
Any suggestions? Actually, the ones that we have in the default, we got it from looking at the WMT data. So in the repo from Comet, you have some histograms there, and it shows how we came up with these thresholds.
Yeah.
But it basically depends also on what kind of threshold you are willing to accept.
The reason why this is actually you can use this and move these thresholds, it's because depends a lot on the use case. Maybe for a specific use case, and even for language pairs, since the scores might change a little bit for language pair, might be unfair to give a red bucket max threshold of 0.10 for language pairs where the predictions of score tend to be lower. This was for English into German. But yeah, you more or less have to look at the data to find where you believe that the threshold fits better.
But as a rule of thumb, you can start with these ones that we have into default, and it should be okay.
But we also have this segment level comparison plot. We don't have a lot of data points, but with more data points, this becomes clear. Whenever you have a bigger blue ball, it means that the difference between the two translations, according to the segment level metric that you select here, it's higher. So the bigger the ball, the bigger the difference. Here we can see that, okay, in this case, it's very easy to spot the difference because
segment is also very small.
Yeah, the segment is very small.
But if you go, for example, here.
Yeah, this one, maybe I can zoom in so people can see it.
Yeah.
So here you have the named entity again, Alston, that is being translated to Austin.
It's being translated wrong in the Y system. So that's why in the Y you see you have like 0, minus 0.2, but it's actually performing really good in the X system. So like more than 0.8. So this is one kind of things that actually it could be very useful to see where these outliers are and why two systems are different, because sometimes you are actually comparing two systems that might be very, very similar. You just do a small improvement or you just change something in the training, and you want to make sure that you don't have these kind of outliers.
Yeah. And finally, because we are running out of time, we also have a very simple histogram plot, just so you can check the overall quality. This is not going to add you a lot more information after seeing the other two plots, but it kind of summarizes what you have seen. And
maybe let's show just because of time. So here you just did you just do the bootstrapping like we were doing before. But another cool thing that we have, for example, the filters. We have 3 implementers. The first one, the duplicates, is not very useful. For example, in this data, we were using it by default, but actually we didn't have any duplicates. But for example, the name entities, if you select it, it should start running like we're seeing. And it basically will select the segments of this corpus that has name entities. So you are looking into a specific problem, you are focusing on that. It's applying, so it might take just a little bit. Okay, no, it's actually fast.
I'm using the GPU. But
because he's using GPU, so for you it might be a little bit slow. You just need to download the models, the sensor models that are used to detect the name entities. But once it's done, then you need to download that again. And we can see that the corpus is reduced in 30%. So we don't have a lot of segments with name entities. But again, we can do now, just looking into name entities, the same kind of analysis and same kind of trend actually that we have been seeing through the workshop. That is, the system X seems to perform worse than the other system. And here again, like all of these sentence here, because they relate to name entities, they should have name entities problems, and we can also go through the ones that are more outliers, so bigger and darker, and to compare.
Yeah.
Finally, we want to talk to you about also another kind of filter that we call it like segment filter. So it's very easy to understand. So basically, for example, some systems tend to perform worse when they have longer sentence. So here you can set to choose, for example, the top 50% of longer systems that you have into your corpus. So here I'm removing the name entities, otherwise we are left with very few data. And let's see if the trend keeps the same. but you can choose the percentage that you want, longer or shorter, or even something in between. But basically the idea is to give you tools to do this very easily and to segment to the things that you want to look for. Because sometimes when we are comparing, we might be worried about certain things, name entities or longer segments or shorter segments, or another filter that we might have. So I don't know why it's not running, but it should run, and it could change the overall scores of the systems. So for a longer segments, maybe the other system was performing. So is empty telescope for comfortable manual inspection of systems? Yeah. I don't understand the question. Is for comfortable manual inspections. It is, yeah, it should be a way of you looking manually if you have some doubt and you want to compare two systems outputs. It was basically done for that. Yeah. So when you do it in the command line, I don't know if you are doing, but it also saves you in the folder this kind of plots. So that then you can look manually.
Yeah, you don't need to do it on Streamlit, and the idea is not to be just a Streamlit app. It's actually more in our use case at Unbabel, we use it more through the command line than we use it on Streamlit, but yeah. It's still.
And for example, if you want to avoid looking to the plots manually, for example, these kind of filters of the name entities or the segment length, you can do that and only look to the corpus score. Like we were doing, it's just a way of trying to move deep into these different perspectives. Yeah, just to, if you want to perform the bootstrapping, just to keep it running.
Yeah.
I know what it is. Yeah, actually, you cannot perform the bootstrapping if you have the less.
Okay. Didn't hear that.
Yeah.
So we just found the bug on my tool. Thanks.
No, I found it already. So the bug is if you run with the segment length, actually the bootstrapping doesn't work, but we'll fix it. So I don't know if this was useful for you. You were very quiet, so it looked more a monologue, but with some interactions on the chat that we really appreciated. But you have an extra challenge. So if you want to go ahead and maybe think about features that you would like to see on Empty Telescope, just talk to us, or even try to do it yourself and do a merge request on the repo. We will share the links, but we also have the tutorial. I don't know, we will try to keep improving. And if you have any comment, we are free to ask now or later.
Yeah. We try to, even if not now, but if later on you send either me or Catarina an email, or if you open an issue, we try to be fast at answering it.
Bottom line, we just want to increase the use of different metrics and a more fine-grained analysis when comparing to systems. So for a better of the community, as a community, either in the industry or research, so just a better habit, and try to do the tools to do it more efficient.
Yeah, and you can ask Taya if you want to work on uncertainty for empty evaluation. She's also there.
Yeah. So Marina.
Okay, well, thank you, Catarina and Ricardo. It was an amazing presentation. And yeah, let's go now for an hour break and see you later in the afternoon for the hackathon. Thank you, everyone.
Thanks.